Somewhere out there, a star collapses, forms an event horizon, and by every equation we have, creates a singularity, a point of infinite density where physics breaks. But what if that singularity isn't an ending? What if it's a beginning, and what if it happened to us? A small but serious group of physicists have proposed exactly that. They call it black hole cosmology, and the claim is that our entire universe, every galaxy, every star, everything we can ever observe is the inside of a black hole that formed in some larger parent universe. It sounds like science fiction, but it comes from real general relativity. Physicist Nikodem Popławski proposed that when a black hole forms and a wormhole opens up to a white hole on the other side, a brand new universe is born there, expanding outward from that white hole. In his model, space-time has an extra ingredient most people have never heard of called torsion. At extreme densities, torsion acts like a repulsive force, so instead of crushing down to an infinite point, collapsing matter bounces, and that bounce becomes the Big Bang seen from inside. Here's the detail that makes this more than a fun thought experiment. This bounce naturally produces a period of extremely rapid expansion, which looks a lot like cosmic inflation, the thing our own universe actually went through right after the Big Bang. In 2025, cosmologist Enrique Gastenaga and his team published a version of this idea in Physical Review D. They calculated that a collapsing cloud of matter, stopped from total collapse by simple quantum mechanics, could bounce and produce both inflation and even the accelerating expansion we blame on dark energy without needing either as a separate ingredient. That is genuinely attractive because inflation and dark energy are two of the biggest unexplained patches in our current model of the cosmos. We use them because the math demands something like them, but nobody has ever directly detected either one. There's also a strange numerical coincidence backing this up. If you take the total mass of our observable universe and calculate what its Schwarzschild radius, the size of the event horizon that mass would produce, it comes out almost exactly equal to the actual radius of the observable universe. That could be a deep clue, or it could be a coincidence with no physical meaning at all, since our universe isn't actually shaped like a static black hole. Coincidences like this have fooled physicists before. Some researchers have also looked at how galaxies spin. Multiple surveys, including recent James Webb Space Telescope Deep Field images, have reported more galaxies rotating one way than the other, which would make sense if our whole universe inherited rotation from a spinning parent black hole. But this evidence is contested. Other teams analyzing the same kinds of data find the spins look random and argue the apparent pattern comes from how brightness and dust bias our measurements rather than any real cosmic rotation. And the biggest problem for the whole idea remains simple. If our universe were literally shaped like the inside of a single black hole, we would expect strong signs of that geometry, a preferred direction, a detectable curvature, some real asymmetry. Instead, the cosmic microwave background, our best baby photo of the universe, is isotropic to about 1 part in 100,000. Gastenaga's team says their model isn't just philosophy, it makes a real prediction, a small but measurable spatial curvature to the universe, something upcoming missions could actually go looking for. If that curvature never shows up, this whole idea dies quietly the way most bold cosmological ideas eventually do. So no, we cannot say we're living inside a black hole, but we also cannot rule it out, and that tension is exactly why this idea refuses to die. The Big Bang might not be a beginning at all, just the moment something much bigger swallowed a star and gave birth to everything we've ever known. If you want to keep chasing questions like this, subscribe, because the universe still has a lot of explaining to do.